All right, all right, all right. Give me just a moment to get things set up here. Check, check. Check, check, check. All right. All right, all right, all right. We're getting started here. Let's do this. Make sure we're good. All right. All right. Let's get started here. It's good to be back on the Twitch. Let me silence these notifications. They're gonna bug me if I don't. It's gonna be back on Twitch. It's gonna be back on YouTube. We gotta get our screens organized here. I gotta remember where we left off. I should have looked at the video. Anyways, you're on the Twitch live stream of GROM's Club. It's a GROM's NFT project. Yeah, we got big things going on at GROM's, and you should go check it out. All right, that's all I'm gonna say. No, I'm gonna say more. We're closing our focus in. We're gonna be making a lot of changes to the NFTs, not the NFTs themselves, but supply, things like that. And the focus of the project is going to be it's a tighter focus and a little different. But what I can tell you is the skills here that we're going to learn in these streams and videos where we learn Rust and we learn Solana development, they're going to be very important going forward in GROMs. So get in here and learn this stuff. And even if you don't want to be part of GROMs, like, this is probably one of the most valuable skills you can build right now. And it's hard. It takes time. It takes focus. And I'm not a good example of that, but I'm trying to get better. And doing these streams has made a big difference for me. So thank you for being there to watch. Thank you for being here on Twitch. Thank you for watching on YouTube if you're watching this on YouTube. But yeah, I'm really excited about this. I'm starting to, like, I was just having a conversation. I'm going to do a little ramble here before we get started, because these, it's kind of what this is all about, right? I'm just kind of rambling, talking about how I learn, explaining as best I can the way I understand things, because I think that helps me understand it better, and it helps people learn it better. So, like, I'm like kind of like self-taught web dev, right? I don't have any computer science degree. I've taken a couple of junior college like computer science classes, which is like really like basic rudimentary programming, like for loops and variables and functions and all that stuff. And then just a very little bit of like data structures and algorithms. But the thing about Solana, right, is it's like, it's not like building a website where you can just code, JavaScript or whatever, and then like you can see the difference. You can see like the fonts and the words and all that stuff and pictures. Solana, it's like, it's hard because like it's kind of like this ephemeral state. it's like a shared computer. And I was talking about this with like some like a Solana employee, Chase, and then another guy with Darkfire, Parasite, and I was like, they were talking about like, you know, how like we get experienced developers to learn Solana, and you know, the thing that I've come to understand is like Solana is like the reason it's hard. Part of the reason it's hard is because if you're a self-taught web dev, you've never really been exposed to computer architecture in a really like basic, like a low-level way. Like you've dealt with like frameworks like Rails or Node, you know, Express, whatever, or Python and Django and stuff like that. But you've never like worried about like memory for one thing, obviously, but also like where the stuff, where and how the stuff like is stored at a very low level, like very low level information. Like you obviously may have done like database stuff and SQL and all that, but this is like much more low level. And Solana is like, it's like this weird computer architecture. So these kind of abstractions of like ideas of like programs and accounts, they're not very intuitive if you haven't like dealt with those paradigms before. So I hope that me explaining them, one, it is like helping me understand things better. But two, I hope they help you understand things better. And you can reference these videos. You know, my recommendation is that that you try to work this stuff on your own, but also like watch my videos when you get stuck, or maybe before you hit a point. So let's see. You know, I'm gonna skip to the. I'm looking at off screen. I'm looking at. I want to bring this up. Hang on. I'm going to mute it so you're not blasted. So let's see where we left off. Yeah. All right, so we're looking at like the API of our program. Okay, cool. That's all I need to see. Yeah, so we were talking about the flow of the program. We walked through that. We kind of drew it out a little bit. We talked about the different. I think we talked about this. Remember, we have two parts. Alice and Bob. You know, so we have all these programs. Let's bring up our handy dandy guy here. Well, this may like actually. This may give us enough here. Yeah, we talked through all this too. Yeah, it's actually, I think we're farther down here, right? Man, now I'm really worried. I'm skipping a bunch of stuff. Yeah, no, here's where we were, right? Okay. I think we should have this in our code, right? Get rid of that. Dogs will be wilding out. I don't know if y'all hear that. Yeah, so we're putting these all in comments here just so we have reference to kind of what the different accounts are. So one thing that's tricky about raw Solana is that like we have to keep track of all these accounts through the whole program. So we need account 0, and specifically account 0 the signer, because transferring the ownership of the temporary account requires Alice's signature. We're referring to Alice as the initializer and Bob as the taker. Okay. Alice knits the escrow. Bob takes a trade. Great. Okay. Account 1 is a temp token X account, which needs to be writable. This is because changing token account ownership is a user space change, which means the data field of the account will be changed. So we have our, you know what's tricky is like I can't scroll and draw at the same time. Because I haven't figured out too yet. So remember we have all these, let's just write this out real quick again. So we have Alice, oh yeah, hold on. I mean, minimize this for a moment. We have Alice's account. We have Bob's account. These are their main accounts, right? This is the ones they have private keys and public keys for. Well, they have private keys for, right? That are functionals. Because remember, when we have different tokens, we have separate accounts for them, and we don't have private keys for them. I mean, we do. I think we do have private keys, but they're not usable. The way you change ownership or the way you transfer tokens is to tell a system program with a signed message. This is system program. So once that's just like, that's kind of a god level program in the Solana blockchain, if you want to think about it that way. So this is our escrow program that we're going to deploy. And we have an X account. We have a token. These are different tokens, right? Token Y account. Hope that's clear. That's an X. Yeah. Okay. And then Bob is also going to have eventually. These are more in states, right? Bob is eventually going to have an X account and a Y account. So account 1 is a temp X token. This because changing. So what we need to do is we need to get, and I don't remember who gets what. So account, which will be, I don't remember who wants which token. I think Alice wants a token. Okay, so Alice has, so here it says account 1 is a temp token, which needs to be writable. This because when changing token account ownership and the user space change means the data. So I believe Alice wants to transfer her X token to the escrow program so that when Bob transfers his Y token to the escrow program, they go to each other. And that is Y, not X. All right. And then so like we also, yeah, man, this is probably like an evolving diagram. So I'm gonna let this fade. I'm gonna leave the system program off because we don't need it for now. We just know that works that way, right? Alice. These are their main accounts. They have X, Y. X and Y. And just a quick refresher, right? The escrow account, the goal is to make a kind of a trustless transfer, right? Alice wants to trade Bob for some tokens. It wants to do a token swap, essentially, one token for another. So Alice is deploying this escrow program so that she can send an instruction to the escrow program to say, hey, I'm going to send you, I believe, token X. When Bob sends you token Y, send token X to Bob and send token Y to me. So eventually we'll need, like, escrow will need to have their own X and Y accounts. And just so they can facilitate that transaction. Okay. Let's we'll get rid of this for now. We can come back to it, I believe, yeah, okay. All right, so escrow account, which also needs to be read out because this will write all the escrow account information into it. Yeah, it's actually one thing I kind of wanted to highlight. So let's go back to this real quick. So our escrow account, our escrow program, one way to, like, think about this, let me get a toolbar here, just a second. Sorry, I'm trying to see how I can get an eraser for this little screen brush tool. Yeah, I don't know. Anyway, I guess we can just do this. So this is the escrow program. And so this escrow, like, the way it's going to be kind of working, from what I understand, is this escrow program is going to live on the Solana blockchain, and then, like, there'll be kind of these sets of accounts, or state, if you will, for this whole, like, interaction between Alice and Bob. Because that way, if, like, Charlie and David come along, they can still use this program, but they'll have to set up their own accounts. Right? Okay, so there's going to be... Actually, this will be a good way to illustrate this. Let's go back up to this list here. So this account is 0, right? And then this account is 1, because we're going to transfer that to the escrow program. This is 2, because this is the that's the account that they'll once the escrow distributes the swap, it'll send the tokens to account 2. And so what we need to actually do here is to properly represent this, I think, is to have this other account so the escrow program. So remember, this is the thing about Solana, right? The program itself on the chain doesn't hold any of this state. So all this information about how what token is going to be sent back and forth. None of that is encoded into the program. The program only has the logic for accepting this information and knowing what to do with it. So what we need to do to hold that information, like who is which accounts are going to be part of this execution, series of executions, needs to be stored in an account. So we're calling this escrow AB account just because it's escrow Alice and Bob, and that's 3. So, just to illustrate this, to drive this point home, later on, at the same time, even in parallel, there could be another escrow account over here that's using the same logic of the on-chain program, but it's for Charlie and Dave, and there's let's say, I don't know, I'm gonna pick some random letters here. They're doing the same thing, but let's just do let's say they're doing M and N, right? And then so the escrow Charlie David account will have its own M account, token account, and its own N token account. And so thus, eventually, not yet here, but the escrow Alice and Bob account will have an X token account and a Y token account. So we can facilitate this trade. So and this is, something I struggle with, I think, to understand for a while, is that the escrow program is stateless, right? It actually says this in the tutorial earlier, last video, we went over that piece. And this is a key component to Solana development that's different than Ethereum, from my understanding. So the escrow program is stateless. So it has logic to facilitate the transaction, but it's not going to know, it shouldn't know what accounts are involved in this escrow swap, so that it can be generalized, right? So this escrow Alice and Bob account for token XY can happen, and this escrow for Charlie and David can happen with token M and N. So we're using Alice and Bob as this instance, but you could swap in Charlie and Dave and M and N token, and it'd be the same. But we're just cross this out for now because we're not working with them. We're just using Alice and Bob in our example. But that's the idea. So all right, so yeah, so that's 3, and then we have 1 and 2, right? And 0. 0, 1, 2, 3. So rent sys var, yeah, so this is, I think he talks about, down here. Rent's a, I guess I should talk about this now. Well, he says, I'll explain this in detail when we get, all right, well, we won't worry about rent sys var right now. But when we see it, we'll definitely talk about it. The token program. What you should remember for now is that account 5 is the account of the token program itself. I will explain why we need this account as well. Oh, I messed up. So earlier I said, I had the system program up here as kind of this god level program, but it's actually a token program. That's going to kind of administer these or maybe you can think of as facilitating the transactions. So when we move this X account to the escrow program, or I think it's X account, I forget. Anyway, when we move any of these token accounts around or transfer tokens, we're doing that via the token program. So it's just saying we need to indicate that in this escrow program. Because theoretically, there could be the token program is kind of like the Solana standard. So everyone kind of agrees that that's the program you use to define your SPL tokens. But, I could create, if I wanted to, I think I may have talked to this Adams tokens, or, and then that would facilitate whatever. But I'm not doing that because, I'd assume, I don't know for sure, but I would assume if you did that, you'd lose some composability. The token program is just like, all the big tokens obviously are using it. So yeah, so we just have to indicate that in our program. We'll need that. What you should note, account is account token program itself. I'll explain why we need this account as well when we get to writing the processing code. Okay, processing code. Solana has sysvars that are parameters of the Solana cluster you're on. These sysvars can be accessed through accounts and store parameters such as what the current fee or rent is. As a Solana program version, sysvars can be also accessed without passing it. Okay, so so rent is like, so we have to pay Solana coin essentially to store data on the Solana blockchain. This is so like, people don't waste space on the blockchain. And so what it is like there's a certain amount of LAN ports, which are like the minimal, like the smallest denomination of a Solana coin or Solana token. It's called a LAN port, and it's a certain amount. I don't know what it is off the top of my head, but depending on how much data you're storing, you can pay that rent that'll like slowly be deducted from this account's balance. So every one of these accounts actually has a small amount of LAN ports associated with it. And as it's being stored, the validators will deduct, I believe the validators do it, will deduct that amount from the account's balance. And if the account's balance goes to 0, the account will be like forgotten basically from the Solana blockchain. So one option that you can do with rent is pay enough to store the account for 2 years. And then you actually won't be charged anything. The Solana won't like leave, or LAN ports won't leave the account. It'll just stay there. So yeah, that's kind of a little context on rent, and I'm sure we'll probably get into it more later on. So this is just like talking about the way this rent is handled. So the way this tutorial is originally written, you have to pass the system variables for the rent into the entry point as an account. But you don't have, but going forward, you won't do that. You won't actually do that. All right, so let's go on some more here. So just bringing our code back up just to take a look. We have this init escrow, which just this is how much Alice, this amount variable we're defining here is just how much Y token Alice expects to receive. So this amount is not provided through an account, but through the instruction data. So I don't know yet, because I'm curious to find out. So we have this account right here. I was under the impression that when we initialized our account for this instance of this escrow program transaction flow, that that we would send that data into the account and store it there. But according to this, we're passing it via an API call. Or this amount is not provided through an account, but through the instruction data. Yeah. Yeah. So if I'm understanding correctly, when we call this later on, and this we'll call our program with a TypeScript client, I'm assuming we'll provide that amount that goes in the escrow struct, or this amount here. Yeah. Okay. All right. So I'm actually gonna take the time, I think, to type this out. So bear with me. We haven't gotten into stuff on the Rust streams like structs and enums and impls and all that stuff, but we will. Just one thing to like notice that's really cool. This is about Rust is like you notice like so all these comments I have here when I come in, thanks to Rust Analyzer in my Visual Studio Code, I get to see all that information that I've got here. So when I call in an escrow later on, you know, I'll get all this good information, documentation essentially. Like this is actually providing a link here, I believe. Yeah. All right. So this is a public function for the escrow instruction. Let me just get these things silenced here. All right, I'll take a unpack. We're returning a result of self and program or program error. You're pulling off the first oops. Been right. Oh, I forgot my semicolon. Yeah, we don't have our invalid instruction error here yet. Just gonna complain about that. Yeah, so we're splitting out the first tag here. I believe match on this tag to see if it's a 0. Amount. We're getting the amount from the instruction data. Oops. What's up here? That's invalid instruction. Got a little bit sloppy with our brackets and parentheses. Let me. So I have my microphone in front of my face, so it's like blocking keyboard. I'm not doing so well with it. Let's see here. What am I messing up? Probably got an errant. One of these guys. I didn't. What am I doing here? I see. So it should be right, actually. Mesh tag. So let's see. We got our parentheses. Everyone close parentheses. That's right. Our match statement, open and close. Yeah, that's right. So open and close. Yeah. Amount. Let's see. Email and stream. See what I'm doing wrong. I'm gonna write again because I want it to feel right. Keep better. Oh, I think that's what it is. All right, so let's, there we go. Turn. I just don't like that this doesn't really exist yet. Yeah. It should be here now, or have I not? Oh yeah, I haven't defined unpack amount either. That's next. Okay, cool. We're good. Yeah, so basically what this does is it takes a tag off this first piece of the instruction, splits it off, or returns an instruction or invalid instruction error if it doesn't work, and then it checks this tag that we pulled off the front of the escrow instruction unpack or stuff to be unpacked, and it matches. If it's 0, it returns the escrow enum or amount. Excuse me. Is that right? It's an enum. Yeah. 0, and it unpacks the amount using the rest of that data and stores it in the amount variable. Otherwise it just returns this invalid instruction error, which we've got to define. And then we also need to define this unpacked amount function. Thank you. This is like typing. All right. So we're getting some dicey territory for me, so I'm gonna have to like probably look some of this stuff up. Sure, we're far away. We're not gonna get very far today. That's good though. And then we're returning our okay. Why doesn't it like that try into? So nice try. Huh. That is what our current scope option is going to be used with the tracing scope. We have like a use super. What is it? All right. Well, let's look at. We can see if that's. Oh yeah. Yeah. Okay. So what happens is like the instruction comes here. This unpack figures out what it's supposed to do with it. I believe later on we add more options to this match to route the instruction to different places for it to be unpacked. And here we're just unpacking that amount variable. Let amount input get certain index of the array of 8 bits unsigned integers coming in. Slice trying to. I'm still not sure. I don't know if this is like a new Rust thing. Now I'm starting to worry. Does he have that up here? Oh yeah, we didn't add the use. That's why. Okay, well, that makes sense. So at some point, I decided I need a buff read, but we don't need that. Let's get these all in here. This comes from the Solana library. I don't have to do it. And then we're going to so we're asking for this. We don't have it yet. No, it's going to go snare too, right? Sorry, I've been bindings are acting weird. Okay, so yeah, so that cleaned up our trying to and our error just because we're trying to import it, but we don't have it. So let's talk through this stuff real quick. So we're unpacking this amount. We're returning a result that will either be the actual amount or this program error. Remember, this is the amount that Alice expects to receive a token Y. So yeah, so .get returns a reference to an element of subslice depending on the type of index. So this gives us like a certain index, essentially a certain index of our array of unsigned integers. And then returns none. We use this. What do you call these things? Crap. So let's see. It's like it's a little function, right? A little anonymous function. Dang it. I'm curious. Closure, right? Rust closure. That's what they call this. Non-function capture there. Yeah, closure. Okay. Anonymous function. There's a little small function in here that we try to. So what do we performs conversion into self? So I guess this is where we're. Oh, crap! Sorry, hope that wasn't noisy. This is where we're like trying to convert this U8 slice into a U64, I believe. And then map the U8 to the U64 using little Indian. I create a native Indian integer value from byte array and little Indian. All right, so this is some like low level coding, like encoding stuff that I'm not terribly familiar with. I've heard of little Indian and big Indian, and how there's like Anyway, we're not gonna get that low. We're not gonna get into that, but that's an interesting topic if you want to dive into to understand that. And then, if all this doesn't work, then we throw out this invalid instruction error, which we have not yet defined. That's why it's complaining to us here. All right. Yeah, so we can read through Paul's explanation here. I just saw, I should mention, Paul was on the latest Solana podcast with Chase. Solana podcast, chewing glass. It's the first, actually. Yeah, anyway, just search for Solana podcast and listen to the latest episode, or the one titled Chewing Glass. So the guy who wrote this, Paul, he's on there. So pretty cool to listen to that. I'd never heard his voice before. I chatted with him a little bit briefly. Okay. So the unpack expects a reference to our slice. This is we're not changing this, so it's just a reference, not a mutable reference. Look at the first byte tag to determine how to decode using match the rest of the slice. For now, we'll leave it one instruction, ignoring. So yeah, we're gonna have other options here in this match. You can look at the individual. What's most important for you to understand is what's unpack function 1, choose which instruction to build 2, and return that instruction. Yeah. I think this is just this is like a recreation of, this is the same information we read earlier about this as far as right here. Okay. So let's knock this error out, and then we'll try to knock this section out. Create a new file. I think we already created that file. So let's close this. Yeah, error. We need to get this dependency in our cargo log file. Oops, our cargo toml file, excuse me. Look at this. Solana program 1.9.4. Huh. Was that? I may be like a. Sorry, I'm checking to see if that is what. Yeah, was this always here? When was it updated? It was updated yesterday. Look at this. Or no, it was updated. Yeah, it was updated a few days ago. So that's why my dependencies are different. Cool. All right. Well, let's update that. Sorry for, hope this isn't hurting anyone's eyes. So let's update our Solana program. I should actually, sorry, I'm going to go back here. I wish there was where's the, anyway. Yeah, let's just do, sorry, I need to check this other stuff in the cargo toml. All right, so he is using 2021, so that's good. I was nervous that I would have some issues. But now that we're seeing the latest versions, I'm happy. I'm less. Does it say this 1.9.2? Maybe because that's all I have. Let's bring a terminal up real quick. I'm just gonna run a cargo build. Okay, that'll build. Okay. Go ahead and get our other stuff in here. Okay, yeah, it's updated. All right, back down. Look how long this thing is. All right, so we want this error crate 1.0.24. All right, I should have. Okay. I'll run this again. I'll run cargo build again in a second. Let's get this error in. Just bringing okay, so this should clear up our error over here. Not instruction. Why doesn't like that? Oh yeah, I need that. I don't have that, do I? No, I don't. Module from the Solana program. Great. Ow. All right, now still. Okay. Oh, right. We gotta implement. All right, so let's talk through this before we type the next part. What we're doing here is defining an error type. Instead of having to write this, this just makes it easier for errors, for us to handle errors within our code. We use this error notation. This becomes especially useful when we add more errors later on. So like we're going to have this whole file of different kinds of errors. That way, when something goes wrong, we can send good information back. Yeah, so looking back in instructions, we see that the compiler says no way of turning an escrow error into a programming error. The trait is not implemented. Okay, so let's implement away. So like escrow error is just becoming a more specific type of program error. And we got some green. We're implementing a generic trait, specifically from the from trait. Remember, this is to handle like our when our instruction fails, to make this conversion, I believe. Is that right? Crap, what was that? Try into. Okay. Let's go back to this. To understand what is happening here, we're implementing a generic trait, specifically the from trait. Oh yeah, right, it's in there. Which the question mark over to use. To implement this trait, we have to implement the from function, which carries out the conversion. The program error enum, which is can I go to the documentation from here? Yeah, I can. Okay, so this is like inside the Solana program library. You can see up here. Allows on-chain programs to implement program-specific error types and see them returned by the Solana runtime. Right? Okay, so that's important to know, right? So we need this program error. We need our escrow error to be of like a program error type, so that the Solana runtime will return it to our clients. The reason we do this conversion in the first place is that the entry point or result returns a result of either nothing or a program error. So let's go back to our entry point. Is that actually so program result? So this program result, let's go to it, right? So look at this generic, either the response here or the program error. All right. All right. Man, that was good. Cool. All right, I'm gonna close this out. So we've got we're gonna start here. Grab and put that, dump that in the chat. This is where we're starting off next time. Next time we do a Solana programming stream. Raw Solana. Cool. I'm feeling better and better about this. There's still some like kind of fuzzy stuff for me around here. Like, why are we going? I mean, I'm assuming there's like what the like why. So here's what I'm gonna make a hypothesis about how this is working. Our instructions are, well, see, yeah, here's the thing. The instructions are U8. They're an array of U8s. Instruction data is an array of U8s, and we convert it to U64. So clearly, like, we declared that variable is a U64 here. Why? I'm sure there's some constraints around why this is not an array of U64s in the first place. But that's probably, yeah. So I'm curious about that. I don't know. We may find out. We may not. Space reference. Yeah, I don't know. Anyway, we got far. We did well. So next up, what are we doing? We're starting the processor. That's cool. Starting to get serious. All right, y'all. Thanks for hanging out and learning raw Solana with me. Remember to check out the GROMs Club NFT project and consider minting a GROM with a URL at the bottom of the screen. It'll also be in the description of the YouTube video. We're going to be focusing a lot on GameFi. And my goal is that our community of GROMs is like, we're going to find all the best like GameFi opportunities and take advantage of them, and also learn how to build tools to make us be able to do that better. So that's like some alpha leak at the end of this video. If you made this far, you got a little alpha. Come check us out. groms.club. paddleout.groms.club is where you can mint. You'll have the links to Discord, Twitter, all that. This video will be up on YouTube later if you missed the stream. All right. Talk soon. Thanks for hanging out. Bye.